This video we are going to discuss NEET 2025 chemistry questions. Our first question is statement type. Statement 1 is ferromagnetism is considered as an extreme form of paramagnetism. Here if you see ferromagnetism, which is said to be the permanent magnet, permanent magnet, where paramagnetism is not a permanent magnetism, and this both the magnetism will have unpaired electrons, and here they will have a strong attraction in magnetic field, but paramagnetism is weakly attracted in the magnetic field. So the given statement, ferromagnetism is considered as an extreme form of paramagnetism, is correct. Statement 2, the number of unpaired electrons in chromium 2 plus. So chromium 2 plus has the outer electronic configuration as 3d4, 4s2. So when 2 electrons lost, the configuration becomes 3d4, 4s0. So we have totally 4 unpaired electrons present here. And if you go for neodymium, which is plus 3 f block element, you can find f orbital to have 4 electrons and 5d0 and 6s2. So if it lost 3 electrons, now the configuration becomes 4f3, 5d0, 6s0, and hence the number of unpaired electron is 3. So as the statement given, the same as that of neodymium plus 3 ion, which is not possible. So statement 1 is true, but 2 is false. Our next question, for the reaction A, which is in equilibrium with the 2B, the backward rate constant is higher than the forward reaction rate constant by the factor 2500. We know that equilibrium constant can be written as the ratio of rate of forward divided by rate of backward, which is said to be 1 by 2500, because the given data has Kb is equal to 2500 times the Kf. So I can write Kc. So what is the relation that connects Kp and Kc? Kp is equal to Kc into RT power delta Ng. Now how to calculate delta Ng, which is nothing but number of moles in product minus number of moles in reactant. And that is equal to number of product here is 2, number of moles in the reactant is 1. So a delta Ng is going to be 1. And here we can now substitute Kc value, which is 2500 reciprocal of, and 0.0831 R value, and given temperature is 1000 and to the rise to the power minus 1. And after solving this, you will get the answer 0.033. So here the correct option is second option, 0.033. Next question is total number of possible isomers, both structural as well as stereoisomers of cyclic ethers of the molecular formula C4H8O. So let us go for isomer formation with this molecular formula C4H8O. My first cyclic ether is this one, and we can try for the 4-membered ring, leaving one methyl group out like this. And here can you find a hydrogen here and one methyl group and one atmosphere of oxygen and another with a CH2 group. So here arises a asymmetric carbon. Whenever there is asymmetric carbon here with no plane of symmetry and axis of symmetry, it gives you D and L isomers. So here due to the optical isomerism we have 2. And the next one is, and I'm putting methyl group away from this O. And now we have 1. And the next one is 2 methyl group in the same carbon, and tricyclic. Here we have 1 methyl group, this one, and another methyl group here. You have to concentrate here, children, because when these two are in the front side, we'll have trying to have a isomer. However, due to the plane of symmetry, there is no optical isomers arises here because of plane of symmetry. And what about the next one? Here we have 1 methyl group front and 1 methyl group at the back, which do not have any plane of symmetry here, and hence it rises to optical isomers D and L. And what about the last one? The last one is putting 1 ethyl group here, 1 ethyl group, 2 carbon in the same site. Here we have an optical center again, and here again we have a 2, that is D and L. So totally how much? We have a answer 10. Next question is given below are 2 statements. Statement 1, a hypothetical diatomic molecule with a bond order 0. We already know that if bond order is negative or 0, the stability is not there. isn't it? So statement 1 is not true. And if you go for second statement, as the bond order increases, the bond length increases. We know the relation that bond order and bond length is inversely proportional. So say statement 2 is also wrong. So the correct option here is statement 1 and 2. Both are false. Next question is organic question. So we have a ester group here. So if you take this diisobutyl aluminum hydride, which acts as the partial, which makes partial reduction of ester. So this particular reagent is meant for partial reduction of ester. As a result, you can find the bond cleavage around this OCH3 leading to the formation of benzaldehyde. So other options are also reducing agent to this particular reduction of ester. The best choice is isobutyl aluminum hydride. And the next question is major product of the following reaction. We have cyano group as well as keto group, and here excess Grignard reagent is given. So we know how this Grignard reagent get dissociated, leaving this metal with a positive and this alkyl group as a negative. So when you consider how this attacks both the groups, okay, you can find oxygen being more electronegative, the electron shift will be towards oxygen, and carbon with a positive. Then you have a C triple bond N, where here the C triple bond N, nitrogen being more electronegative. Now nitrogen will have a negative charge and carbon have a positive charge. Then here we have a one Grignard reagent, and here the attack of another Grignard reagent. So this positive will attack this negative, and this negative will attack positive. Negative will attack the positive, and positive will attack the negative. Similarly here, negative will attack the positive and positive will attack the negative. As a result, we have a compound. We have a compound addition compound, that is OMgBr. Here we have one CH3 group. Then here in carbon, another CH3 group, double bond nitrogen with MgBr. This one on further hydrolysis, acidic hydrolysis, you can find the bond breakage like this, leaving your hydrogen here and OH near to the carbon. And similarly here with the nitrogen, 2 hydrogen and 1 oxygen. So as a result, you have the compound. You have the compound benzene ring with C tertiary alcohol arising, and here ketone. Okay, so the correct option here would be third option. So the next question is, if the molar conductivity 0.050 mole per liter solution of monobasic weak acid is given as 90, its extent of degree of dissociation alpha they are asking. So it is given that the infinite dilution conductance are given as 349.6, and for anion it is 50.4. We know that lambda alpha is equal to lambda m at particular concentration divided by lambda m at infinite dilution. Lambda m at particular concentration is given very direct here, which is substituted as 90, but we need to calculate lambda m naught. The lambda m naught is equal to sum of the anion and the cation. So we have to sum up the conductance of both the anion and the cation at infinite dilution, which gives you 349 plus 6 plus 50.4 as 400. Now substitute 400 here. So the value you will be getting as 0.225. So the correct option is option 2. Next our question is, which of the following reaction does not belongs to Lassine test? Okay, and here we have 4 options, and we know that Lassine test is a test which used us to convert your organic salts into ionic form of sodium. Okay, ionic form using sodium. So this sodium will react or combines with elements present in the organic compounds like a halogens or a sulfur or a nitrogen. Sometimes both sulfur and nitrogen gives you isocyanate, isn't it? So these are the Lassine test. So the odd one out is copper oxide plus carbon gives you copper plus CO2 will not come under this category. So the here the reactions that does not belongs to Lassine test is option 3. So 54th question, the correct order of decreasing acidity of the following aliphatic acids. Usually minus I effect is directly proportional to acidity, whereas if plus I group present, it is inversely proportional to your acidity. So here you can find formic acid which have no plus I group, whereas your acetic acid here will have 1 plus I group, and you have a 2 plus I group here, CH3, and here in tertiary forms you can find 3 methyl groups present. So when you increase the number of, okay, when you increase the number of methyl groups, we can find the acidic nature decreases. So the correct order is formic acid, option 2. Formic acid will have the maximum acidic nature. Then comes ethanoic acid. Then comes 2 methyl group and 3 methyl group. Okay. And our next question is match the list. And this is such a direct question from your biomolecules. That is, we all know the deficiency disease of all the vitamins, and it is vitamin D which forms a rickets in children and osteoporosis in women. And here, so the correct option for B is third one. Okay, and for A, if you take vitamin B12, and we know it goes for pernicious anemia, and for C, vitamin B2, it goes for chalosis, and B6 will leads to convulsions. So for this, the correct option is A4, B3, C1 and D2. So option 1. And 56th question, out of the following complex compounds, which of the compound will be having the minimum conductance in solutions? And of course, we have a small confusions. Whenever the number of ions increases, the conductance will increases. But if you find the 4 options, here the number of ion is 0. Here the number of ion is 1 plus 3 chloride ions, which gives you 4. And here 1 complex ion, 1 counter ion, so totally 2. In the last options, you have 0 ions. So they are asking minimum conductance in the solution. So we have 2 options right in this question. The 7th question, this is also very direct questions from your biomolecules. That is option A is found. This sugar X is found in honey. Honey, we know the main ingredient is around 30 to 44% fructose is present. Isn't it? Fructose. And of course, fructose, we have a keto group which is present among the 6 carbon. And this exists in, we have a alpha and beta anomeric forms. So both the things in the cyclic, we know that very clearly. This is 5-membered ring. It leads to the 5-membered ring. Okay, where the first carbon will have CH2OH, and here OH down. If OH present down, it is alpha. Down, and OH present up, it is said to be beta form. So it exists in alpha beta anomeric form. This statement is also right. And of course, they have a the specific rotations around minus 92.4 degree. So of course it is minus dominates, so it is levorotatory in nature. So it is fructose, which is found in honey, which is said to be fruit sugar also, and has a keto group in it, and exists in alpha beta anomeric forms, and has a levorotatory. So the correct answer is D, fructose, option 1. And 58th questions, alkane is given here. When you go for monochlorination, we have to see how many possible isomers existing. So first we have to find out the type of carbon available in the given compound. Can you find, children, here? Here we have a primary, here also we have a primary, and here we have a tertiary, and here we have a secondary carbon. So basically there is a existence of more than 2 or 3 here. Let us check if it undergoes a monochlorination. First we shall write, we will take a primary where I can do my chlorine substitution in this carbon, leading to this isomer. In this isomer, can you find this carbon exists in optical center arises here? So here we have 2 forms, that is D and L. And if I go for attack of this primary methyl group, I can have CH2 here and CH2 Cl, and no optical centers, so only one isomer existing here. And when I go for secondary substitution, I can find CH3 twice, CH, okay, here CH, Cl and CH3. Again you can find one optical center here, and this gives rise to D and L forms. Then you have tertiary carbocation, carbon replacements, that is CH3 twice, and here CH, Cl you have CH2, CH3. And this hydrogen here, it is replaced. We have 2 methyl groups common in one carbon, so there is no possibility of optical center. So totally here 1, 2, 3, 4, 5, 6. Okay, so here we have option 3 as 6. And 59th question, 59th question, we have which one of the following compounds can exist as a cis-trans isomer, geometrical isomerism question. So write down all the structure for the four compounds, where you can find very directly that we have a cyclohexane here, and first carbon with the one methyl group and second carbon with another methyl group, where you can find both the methyl groups pointing on the same direction, then this is going to be cis. Whereas if the methyl groups one above, one methyl group below, which is in opposite form, opposite directions, then we can take this as strands form. So the correct option here is third option, 1,2 dimethyl cyclohexane. Which one of the following reaction does not give benzene as a product? Okay, so here can you find benzene disonium chloride? Or this is such a direct question from benzene disonium chloride, where if you treat that with the water, you will have the formation of phenol releasing N2 gas, whereas in all the other options there is a possibility of forming here benzene C6H6, and here also C6H6. So here the reactions that does not give a benzene as a product is option 3. 61st question, phosphoric acid ionizes in 3 steps. So this we already know, it is a tribasic acid, where your orthophosphoric acid takes place in 3 steps to release 3 H plus ions. So in the first step you can find 1 H plus coming, giving you H2PO4 minus ion. Let us take this as Ka1, the dissociation constant here. And in the second step you can find H2PO4 minus, which is in equilibrium with release of one more hydrogen ion out, and HPO4 minus. Here the dissociation constant is Ka2. And the third step we have one more H plus coming out, giving you the phosphate ion. Okay, here 2 and here 3 minus. So this is said to be Ka3. So you can find the number of H plus which is higher in the first step. So I can take Ka to be much greater than Ka2 than Ka1. Okay. And if I write the total equilibrium for this particular 3-step reaction, I can take Ka1 into Ka2 into Ka3. If you take log on both sides, you will be having log Keq is equal to log Ka1 plus log Ka2 plus log Ka3. It is very clear that option 1 then B, which is strong acid because Ka is very higher here, and C, which is the given order. Okay, these 3 are correct, and D option we won't get. So the correct option would be A, B, C, third one. Among the following, choose the one with the equal number of atoms. So I think this mole concept question, it is very easy to write. So we all know the two formulas. Number of moles can be calculated by given weight by molar mass, and number of moles equal to given number of particles divided by Avogadro number. Using these two relations, now we are going to apply for all the options. If I consider A and calculate the number of atoms, total number of atoms here, it is 2 Na and 1 carbon. Okay, 1 carbon and oxygen 3. So totally we are getting 6, and into Avogadro number of particles into given weight divided by molecular weight, which gives you 12 Na. Similarly, if you calculate for B, where the total number of atoms in B is 2 plus 1, 3. So 3 into similarly Na into given weight here is 248 divided by 62, and that gives you the answer 12 Na. And similarly B, so if you take after BC, okay, we have totally how many atoms? 1 plus 1, totally 3. So 3 into Na into 240 divided by 40, which is equal to 18 Na. And if you work out for D, how many atoms we have? 2 atoms here very directly. So 2 into Na into given weight divided by molar mass, and you will getting 12 Na. And when you go for E, so here we have 1 plus 2, totally 3 atoms, 3 into Na into 220 divided by 44, which is equal to 15 Na. So they are asking for equal number of atoms. We have a 12 Na here, 12 Na and 12 Na here. So the correct option is A, B. A is right and B is equal to that, and D is equal to that. So A, B, D is the right choice. 63rd question, statement 1, like nitrogen that can form ammonia, arsine can form arsine. Of course, what are the nitrogen families? We have a nitrogen, phosphorus, arsenic, okay. Then you have a antimony, Sb and bismuth. All these people will form a, respective hydrides. For example, NH3, then phosphine, then you have a arsine, then you have a stibine, then you have a bismuthine. So statement 1 is true. Statement 2, antimony cannot form antimony pentoxide. These nitrogen family, all can form the trioxide and pentoxide. So this option is actually wrong. So statement 1 is right and 2 is false. Statement 1 is correct and 2 is incorrect. And this is such a direct question, that is 64th question. Dalton's atomic theory could not explain which of the following. So this theory tells you that there is no information about gaseous volume. So here such a direct question, so all the three laws can be explained by this Dalton's atomic theory postulates, whereas the third one is not. So the option is 3. 65th question, the correct order of decreasing basic strength. So whenever plus I group present, which is directly proportional to basic strength of that particular compound. So here let us write N-ethyl ethinamine. So N-ethyl ethinamine, first you write ethinamine, then take one hydrogen and gives you and replace them with ethyl. And next is ethanamine. So ethanamine is actually what? CH3, CH2, NH2. Then you have a benzenamine. So before that benzenamine we have N-methyl aniline. So let us write benzene aniline. Here instead of one hydrogen I am going to put methyl, and the fourth compound is benzenamine. Benzenamine is nothing but your aniline. So you can find, children, here you have two plus I groups, one here and one here. Here you have one plus I group. Here you have a minus I as well as plus I group. Here you have a minus I. So it is very clear that this N-ethyl ethanamine will have more basic nature than ethanamine, than your N-methyl aniline, and the least will be your benzenamine. So the correct option here would be 65, N-ethylamine, ethanamine, then comes your N-methyl aniline, second option.